one thing we'll need to be able to do with polynomials is factor. So let's look at several factoring techniques. First, let's look at a polynomial like x squared plus x minus 6, one which can be factored into integer roots. Because we're starting with a quadratic, we know we'll have two linear terms, so let's write out the framework for those two terms by writing a quantity x times another quantity x, where we'll fill in the root that will go in. To determine our roots, we are looking at the constant of our polynomial, and here we notice that 6 can be written as either 1 times 6 or 2 times 3. We'll need to pick one of these two combinations to fill in the roots, and we'll look at our middle term and notice that it's a value of 1x, so I'm going to pick the 2 times 3 since they're only one integer apart. So I'll write the 2 in one of my linear roots and the 3 in my other. Now I'm going to notice that there's a negative sign in front of the 6, so really I have either minus 2 times 3 or 2 times minus 3. Again, looking at my middle term and noting that it's positive, that means that I need the larger factor to be positive. So I need the 3 to be positive and the 2 will be negative. So I'll put a minus in front of my 2 and a plus in front of my 3. Let's verify that this is indeed the correct factorization. So if I multiply x times x, I get x squared. That's my first term. If I multiply minus 2 times 3, I get minus 6, and that's my last term. To get the middle term, I note that minus 2 times x is minus 2x, and x times 3 is 3x, and then I add those together to get an x out, which matches my middle term. Another type of factoring we'll need to be comfortable with is one that looks like x squared minus 16. This is a special form of the difference of two squares. So let me write that in general as x squared minus a squared, and we see that for our particular problem, a is equal to 4. The form for factoring x squared minus a squared is x minus a times x plus a. So applying that form using a equals 4, we see that x squared minus 16 is equal to x minus 4 times x plus 4. One other type of factoring we need to be able to do is factoring out a common piece from each term. So in this example, x cubed minus 5x squared, I see that each term has an x squared in common, so I'll write that in front. And in the first term, what's left over is an x, and in the second term is a minus 5. This works for even larger polynomials, like ax to the fourth minus 3ax cubed plus 5ax. Let me take a moment and rewrite these first two terms where I pull an ax out. So I see that I have an ax times x cubed, a minus 3ax times x squared, and then I have my plus 5ax. So factoring the common ax out, in the first term I'm left with this x cubed. In the second, I have a minus 3 times x squared, and in my last term I have plus 5. If I consider 5x cubed minus 15x squared plus 10x, again I can identify a common 5 in each coefficient, and there is an x in each term. So each term has 5x. So I'm going to write that out in front, and then I'm going to determine what's left over in each term. So if I pull 5x out of the first term, I'm left with x squared. Out of the middle term, I'm left with minus 3 times x, and if I pull that 5x out of 10x, I have plus 2. Now, if I look carefully at this quadratic that I have here, I notice that this has integer factors. So let us reduce this down to its simplest form. So again, it's a quadratic, so there's two linear terms. So I'll write those out as x quantity times x quantity. And the 2 is 2 times 1. Now, I have a plus sign in between, so that means I either have a 1 times 2 or a minus 1 times minus 2. Because this middle term is negative, I need negatives in front of each of those terms. So I see that my complete factorization of this polynomial is 5x times x minus 1 times x minus 2.